Good afternoon. This is Professor David J. De Los Reyes. I will be conducting a long video this afternoon. This is on my topic, differential equation. I am now on lesson number DE36, and the main topic is actually second order differential equation. I have done with the first order differential equations, so I will now proceed with the discussion of second order differential equations. So for those students who are taking up differential equation, this is for you guys. This is a long video, so don't be bored watching it. Okay, this is for you. My lesson this afternoon is under my long video form differential equation. I am now on topic DE36, differential equation, topic 36. And the title of the topic is second order differential equation. Okay, I will discuss first the concept. Concept is actually the way and how we solve the solution. It's always the concept. If we do not do the concept, there's a problem. Okay, I will try to bring out the form of a second order differential equation. The form is actually d squared y over dx squared plus a constant a times dy dx plus a constant b times y equal to 0. This is a second order differential equation. Second order, it's a quadratic thing, you know. Order is actually the total number of times that a given function is differentiated. So under second order, the power is actually 2. Okay, this is 2, power 2. That's why it is second order. So it's just like a quadratic equation, but the problem is it's a differential equation. So I will try to repeat it. D squared y over dx squared plus a constant a times dy dx plus by equal to 0. The solution of this is actually y equal to a certain constant k times e raised to m times x. There is a constant m over here, m. And since this is quadratic, m should have two values. There should be an m1 and there should be an m2. Okay? And here, since there are two values of m1, m's, which are designated m1 and m2, we could classify three variations actually here. So under variation number 1 or case number 1, if we try to bring out the solution, because under the variation of m1 and m2, there could be three possibilities. That is, the three possibilities are like this: m1 should be equal to m2, and they are both real numbers. Possibility number 2 is that m1 is not equal to m2, and still they are real numbers. That's another variation of the values of m. And for case number 3, m1 and m2, they are not equal, but they are complex numbers. So they should be alpha plus j beta maybe. This is alpha minus j beta. It is, they are complex numbers. So to bring out the solution of a second order differential equation, we will be anticipating three variations of the solution. That is, case number 1, if m1 and m2 are equal and they are real, we got a solution for that one. Case number 2, if m1 is not equal to m2 and they are both real, that's another type of possibility. And the third possibility, the worst possibility, is actually complex thing. That is M1 and M2 are complex numbers. It could be alpha plus j beta, alpha minus j beta. So in here, there is the value j here, okay? And under complex numbers, we needed this one. So actually, case number 3 is, I think it will be on the applications of circuitry, okay? So this is mostly concentrated for those who are taking up electrical engineering, maybe, for case number 3. But for case number 1 and number 2, they are both real numbers. Okay, let's try to bring out the solution. For case number 1, if M1 and M2 are real and unequal, okay, M1 is not equal to M2, and they are both real, this is the proper solution. This is the general solution. That is, y should be equal to k1 e raised to m1x plus another constant of integration, maybe k2 e raised to m2x. That is our GS, meaning our general solution. Meaning, to bring out the solution, we must have to compute for M1 and M2, okay, for a general solution. But if the problem is asking for a particular solution, we should also solve for K1 and K2. Okay? But what I have given here, what is given here is just the general solution. So that is y equal to K1 e to the m1x plus K2 e raised to m2x. So if the problem is asking for a particular solution, there should be an initial condition. For the meantime, we do not have the initial condition, so I just place it here, the general solution. That is y equal to K1 e raised to m1x plus K2 e raised to m2x. In which the value of m1 and m2 are not equal, and they are both real. Okay? Okay, let's proceed with case number 2. For case number 2, M1 and M2 are real and equal. Okay, M1 is equal to M2 and they are both real. If we try to bring out the general solution, we will follow this. Y should be K1 e raised to m1x plus K2 e raised to m2x. But since M1 is equal to M2, we could make this one as M1. Right? Then, using your knowledge of the laws of exponents and the algebra SAT exam. Okay guys, this is for those who are scrolling the SAT exams for the algebra. This is e to the m1x, this is e raised to m1x. That's a common factor, right? That's common factor. So what will come out for the general solution will be y. It will be the sum of k1 plus k2 e raised to m1x. Okay? The common factor is e raised to the m1x. So this is the common factor times the sum of k1 plus k2. That's the general solution under case number 2. It is simpler because m1 is equal to m2. But the problem is, you got still a K1 and K2 over here, and for the meantime, we do not know the value of K1 and K2. Okay? So for the general solution, it should be K1 plus K2 times e raised to m1x, or if you don't want to use m1, you could use m2. Anyway, they are the same, right? Okay? We are not violating anything over there, algebraically speaking. Okay, for case number 3. This is the worst case scenario. M1 and M2 are complex. In mathematics, if we say complex, that number got a real part and imaginary part. I will give you an example under the impedance and AC circuit. The term 3 plus J4 are actually complex numbers. Or is actually complex number. Why complex? because it got a real part and it got imaginary part. Right? So for case number 3, the values of M1 and M2 should be something like this, similar to this. It is a complex number. It got a real part and imaginary part. And for the meantime, we do not know the value of the real part and imaginary part. So we just designated here that the real part is alpha and the imaginary part is beta. So how do we know which real part is? The term with the term preceded by the J sign is actually the imaginary part. So this is real part, imaginary part, real part, imaginary part. So if we try to bring out the solution under case number 3, this should be the solution. These are concepts, guys, on how to solve second order differential equation. I do not have to, what you call this, derive this one, but I could derive it if I would like. So I will just be placing the, what you call this, the simplification of the solution. For case number 3, the solution is actually, if the values of M1 and M2 are complex, okay, it will be alpha plus j beta, alpha minus j beta. The general solution should be y equal to e raised to alpha x times the quantity k1 cosine of beta x plus k2 sine of beta x. Oh, that's the general solution. Okay? So don't be afraid with the solution. We got a cosine here, we got a sine. We are through with trigonometric functions, so don't be afraid with it. That's why I was telling you on the lower mathematics, one of the foundations of higher mathematics are actually trigo plus algebra. Why algebra? Because if you do not know how to simplify, you're gone, right? So for case number 3, the general solution is y a raised to alpha x times the quantity k1 cosine of beta x plus k2 sine of beta x. That is under case number 3. So the next time around, I will be discussing DE37. DE37 will be problems involving second order differential equation. So we will be anticipating which case maybe what will come out. It could either can be case number 1, case number 2, or case number 3. It depends on the given differential equation. If it falls under case number 1, we are lucky. M1 is not equal to M2 and they are real. This is the solution. Case number 2, if M1 is equal to M2, the solution is simpler and they are both real. For case number 3, just in case they are not real, it will be complex numbers. So the variation of M1 and M2 will be, M1 will be alpha plus j beta, M2 is equal to alpha minus j beta. And the solution is this. E to the alpha x, quantity k1 cosine of beta x plus k2 sine of beta x. Guys, lesson DE36 is just the concept, the form, and the bringing out of the general solution. I think that's the foundation on how to solve problems. If you do not know the concept, you cannot proceed with the solution. Okay, for those who are taking up differential equation, this is for you guys, right? So if you like my long video lecture, this is a long video. Please click like. If you want to share it with your friends, or if they are taking up differential equation, you could share it. And if you want to help me, please click subscribe. You will get something from it. Okay, good afternoon, Los Angeles.